Welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question 10 part B from the May-June 2023 Cambridge paper 3 variant 2. This is a question here which is about integration. Part A was about differentiation and is addressed in a separate video. Part B is about integration, and we're told to use a substitution u equals 3 minus 2x. Find by integration the area of the shaded region bounded by the curve, the x-axis. Find your answer in the form a root 13, where a is a rational number. So here we have the equation of the curve. Okay, and we want to integrate this with respect to x between the limits where this crosses the x-axis. So to integrate this, we cannot use the reverse of the chain rule, because if you were to rewrite this in index form, you have 3 minus 2x would be the part that's inside the function, and this is the part multiplying the function. And if you differentiate the part inside the function, you get -2, you get a constant. Here you've got an x term and a constant, so you cannot deal with this by reversing the chain rule. So that's why they have instructed us to use substitution. Okay, so we have to use substitution here. Now, when we use substitution, first of all, I need to know my limits, what the limits are. So I need to know where this crosses the x-axis. Okay, now we know that something crosses the x-axis when y is equal to 0. So that's the first thing I need to do, is to find where this crosses the x-axis, so I can know what limits I'm going to use. So we know that it crosses the x-axis is when y equals 0. So if I replace y with 0, I have like a product of two separate terms whose product is 0, which means that either one of them is 0. So either x plus 5 is 0, in which case x is equal to -5, or 3 minus 2x to the power of a half is 0, in which case 3 minus 2x is also equal to 0. You've got to square both sides, and you end up with x equals 3 over 2. Okay, so this is 3 over 2 here, and this is 5 here in terms of x. Okay, now we have to use the substitution that they gave us. So we have to use the substitution 3 minus 2x. Okay, so I'm going to do that now. So when we use integration by substitution, we always start off with the following. So we're going to find the area of the shaded region. You find the area always by integrating within those limits the expression or the equation of the curve with respect to x. So we're going to integrate y with respect to x, and our limits are, x1 and x2, which are basically going to be 3 over 2 and -5. That should be -5. Okay, 3 over 2 and -5. All right, now if you're going to use a substitution, they want to introduce u, then the way to do it is you're going to now have u1 and u2. You're going to do y dx du du, right? So y is the original function. Y is the original function, which is x plus 5 times 3 minus 2x, sorry, to the power of a half. I just wrote it with the half instead of square root. Okay. And we want to use the substitution u is equal to 3 minus 2x. Okay, so this can be replaced by u. All right, and we need to do with we need to find what dx du is. All right, so I have y here. I need to find what dx du is. Now I can find what du dx is really easily. I can differentiate u with respect to x. I get -2. So dx du is going to be basically minus a half. Okay, and I need to find what x is, because I'm going to have to replace this x with what x is in terms of u. So I'm going to take u equals 3 minus 2x, and I'm going to make u x a subject. So we'll have 2x is equal to 3 minus u, so x is equal to 3 minus u over 2. So now I can put this all together. Okay, and also need the limits in terms of u, which I'll do in a second. But y is x plus 5. Now I can replace x plus 5 with 3 minus u over 2 plus 5. That's x plus 5. And then I have 3 minus 2x, which I need to replace with u to the power of a half. And then I have times dx du, which is minus a half. And then, so this is your y here. All of this is y. So this part is the y part. Okay, all of this. And the dx du part is this part here. Okay, then you have your du. Now what I'm left to do is I need to change the limits to write them in terms of u now. So what we know is x1 is 3 over 2. Okay, and we know u is equal to 3 minus 2x. So u1 is going to be equal to 3 minus 2 times 3 over 2, sorry. So they cancel out. We've got 0. So you're going to have to put 0 on the top here. And u2 is equal to, you're going to have 3 minus 2 times 5, times minus 5, sorry. Because x is minus 5, when x2 is equal to negative 5. So it's going to be 3 plus 10, which is 13. So this is going to be 13 over here. Right? Now, many people will be tempted to write 13 on the top and 0 underneath. No, you put, see, this x1, we know is 3 over 2. And the x2 is equal to negative 5. You put the higher one on top and the bottom and the small one underneath if you were trying to integrate this and you were able to integrate it without substitution. So whatever is in the place of 3 over 2, that value you put where 3 over 2 is. 3 over 2 is on top, 0 is in place of 3 over 2, you put that in the proper place. And whatever is in place of the minus 5, you put that thing instead in the same place where the minus 5 is. Some people will write 13 on the top and 0 underneath, and your answer will come out as negative. It's not such a big deal, although the mark scheme does say the limit's in the correct place. So always, put the correct numbers in the correct place according to the limits that you are, calculating in substitution. So put the limits in the right place, the biggest one on top, the smallest one underneath. When in terms of x, in terms of u, wherever's in the place of the x1, you put the value that comes out when you calculate it in place of u1, right? It doesn't matter if it's smaller than the other number. Okay, so now we have to actually try to integrate. So we need to simplify this a little bit before we try to integrate this. So I'm going to take out the minus a half from the beginning, and here I have 0 and 13 limits, and here I have, this is going to be 3 minus u over 2 times, but I'm going to take, I'll leave that half there. So I have u to the power of a half times this. So this is going to be, I'll write that as separate terms first. So I have 3 over 2, u to the power of a half, minus, this is going to be a half u to the power of 3 over 2. So I'll multiply u to the power of a half by the u. That gives me u to the power of 3 over 2. Okay. And then I'm going to have plus 5 u to the power of a half. Okay. This is integrated with respect to u. And now I can add these two together because they're both the same power. So that's going to be 10 over 2 plus 3 over 2. That's 13 over 2. Okay. So you're going to have minus a half. You have 0 to 13. And you have 13 over 2. Right, I'm saying one number and writing a completely different one. The 13 over 2, because that's 10 over 2 plus 3 over 2. That's u to the power of a half minus a half u to the power of 3 over 2 with respect to u. I'll take out the half as well, so it's going to be minus a quarter. I like to get rid of these fractions. Okay. Haven't started integrating yet, so keep the integral sign. Between 0 and 13 of 13 u to the power of a half minus u to the power of 3 over 2 with respect to u. Now I can add 1 to the power and divide by the new power for each of these. So I have a quarter, I have 0, 13. Now I'm starting to integrate. So now I'm going to write my square bracket and the limits I'll put at the end. That's going to be 13 u to the power of 3 over 2 divided by 3 over 2 minus u to the power of 5 over 2, and you add 1 to 3 over 2, you get 5 over 2 divided by 5 over 2. And I'm going to have 0 and 13 as my limits. So I have minus a quarter times. This is like when you divide by 3 over 2, it's like multiplying by 2/3. So that becomes 26 over 3 u to the power of 3 over 2, which is the same as the square root of u cubed. Minus 2/5. When you divide by 5 over 2, it's like multiplying by its reciprocal, which is 2/5. And this is going to be the square root of u to the power of 5. I'm just putting things in like this form, ready to start substituting values in. So now I have minus a quarter times. If I put 0 into here, both of them become 0. So I have 0 minus, now I've got to put 13 into here. So I have 26 over 3 times the square root of 13 cubed minus 2/5 times the square root of 13 to the power of 5. Okay, so be careful of these signs here. Right, so now what I can do here is that minus a quarter multiplied by the minus gives you plus. So I have a quarter times. So I have 26 over 3 times. Now root 13 cubed is like root 13 times root 13 times root 13. So basically this gives you 13 root 13. Right, that's 13 root 13. Okay, so you have minus 26 over 3. So it's going to be positive now. Multiply that by that. So you got 26 over 3 times 13 root 13. Minus, and then you're going to have here, that's going to be like 13 to the power, root 13 to the power 4 times root 13, right? That's what that's going to be like. So that's like basically 13 times 13. Okay, so it's like 13 squared times root 13. 13 squared, which is 169. So you got minus 2 over 5 times 169 root 13. That's root 13. That doesn't look like a root 13. 1 second. Okay, so we're going to have 26 times 13 over 3. So I'll put this 26 times 13 over 3 minus 2 times 169 over 3. That gives you 0. Hold on. 2 times 169 divided by 3. Divided by 5. That gives you 338 over 5. Okay, so you have, let's do that again. That should, okay, so that's this minus 2 over 5. I think I put 2 over 3 times 169. That gives us 676 over 15. So a quarter times 676 over 15 times root 13. And what's 676? That's divided by 4. That gives you 169 over 15 root 13. A is a rational number. Okay, so there, hopefully we got the right answer there. Let's just check. Yep, that's the correct answer there. All right, so the main issue that the student was asking about was the fact that he got a negative answer when he did his integration, right? And the source of that negative answer, I am assuming, is that he put 13 and 0 instead of 0 and 13. Okay, so normally you put the highest x value on top and the lowest x value underneath when you're finding the area under the curve. Right, unless the curve is below the x-axis where you can switch them to get your area to be positive. In this case, the area is above the curve, all right, and so you put the highest x value on top of your integral and the lowest one underneath, and But when you are using substitution, you just put the u value in exactly the same place as the x value, where the x value should be. Don't think you have to put the higher u value on top and the lower one underneath. You put the u value in the same place that the x value was in your original setup of the question. Okay, so that's the reason why I think your answer came out as negative. Student who was asking that question. So that completes this question. And other questions from this paper, including part A, you can find in the playlist. That will be found in the link that you'll see over here. You'll find a link to the topic of integration of P3 of Cambridge in this section over here, and specifically integration by substitution questions are collected in the playlist in this section. You can subscribe to my channel by clicking on the link above. Thank you for watching and see you soon.